Cool. So now without further ado, I'll be the second speaker of today. So I'll be talking about how to build a basic web application on AWS in high level. So essentially, we'll just touch on the architecture level very briefly, just to give an idea of how you build those in AWS. So now, when you think of the three-tier web application, does anyone know what are those three tiers? Oh, no, no. That's really close. So it's actually the presentation tier, application tier, and data tier. So I'll just explain that in a little bit more detail in the next slide. So what we want to do is based on this scenario, which is the bare minimum of what the three-tier looks like, and we're trying to improve it over the next couple of stages. So this is stage one, which is even if it's not on cloud, any three-tier web application, that's how you tend to host it. So yep, so those three tiers, presentation are normally built with HTML, CSS, and JavaScript. A lot of framework that you might be aware of, like Angular or React, and Vue are getting more popular nowadays. And the application tier is normally known as a logic tier, which you normally write in the programming language and consists of the business logic that supports your application's core functionalities. And the last bit is data, because so as the name suggests, this is where all your data is going to be normally stored, and then normally stored in the database. And popular database system that manage read and write access have the MySQL or Microsoft SQL Server or MongoDB. Does anyone happen to know what's the difference between the MySQL and MongoDB? Just curious. Oh. Right. From the photo, from this image, you might have noticed how do they communicate with each other. So essentially, we try to use we normally use APIs. So, does anyone know what API stands for? Sorry.
Application Programming Interface.
Good on you. 1 point for Aussie team. Yeah, so it stands for application programming interface. So just to cover the basics, so this is a set of protocols that allow software applications to communicate, exchange data. You can consider that as so if you go into a restaurant and obviously you don't talk to the chef directly on what you want to eat, so you talk to the waiter or the waitress, and then that person will deliver your order back to the kitchen and then bring your order out. So that's kind of how computers retrieve the data. So it's not directly talking to the database itself, but it has like a intermediate level where you can obtain the data in a more efficient way. Is that so far clear, or any questions? Sweet. Yeah, so now we jump on the AWS platform. So for the stage one, it's equivalent with what we did for the first image. So we replaced the application tier with EC2, and we replaced the data tier with RDS. So EC2, as Susanna kindly introduced earlier, so this is essentially a server hosted on AWS. And for RDS, it stands for relational database service. So it acts as a database, essentially. So does anyone have any like comments on any improvements can be made on this one? I'll just give you a hint, like if there's a lot of users trying to access and make the request, what's going to happen?
Here another gateway.
Load balance, scaling.
Yes,
that's a good point, but yeah, you learn too much before you come into this session. Yeah, so the first one is normally when you have a lot of users trying to access, your system or your server might be overwhelmed by the amount of requests come in. So you might get an overwhelm emoji on your server. And so what can we do once this happens? Because there will always be a lot of users accessing, and you never know when they can access as well. So
Increase server capacity.
yep, that's one good approach. Yep, that's very advanced topic as well, which we were not going to cover today. But yeah, that's a really good point. So essentially, we want to accommodate those loads by either horizontally or vertically increase the amount of computing power that we can handle. So so in here, this one is horizontal scaling, because we're adding more EC2 services or computing powers to accommodate the loads of the amount of requests coming in. So I'll just briefly touch on the vertical scaling. So this is, you get to choose different type of, let's say, CPUs or memories in the EC2 instance when you're creating them. So if you're increasing so let's say if you're increasing from, I don't know, i3 to i9, and then you get a vertical jump of your computing power. So that's vertical scaling. And for the horizontal is you're adding amount of services into your application tier. So you get more EC2 instance for this case. So that's one way of addressing that. Cool. Now we're looking better than before. So
this is the vertical. This is the vertical one. What about the horizontal?
oh,
If you
so as I said, the horizontal is by adding more EC2 services for this case. So it will accommodate, it will be the same setup or same configurations as the first one. And then when you create a second one, you create the third one. So that's the horizontal.
Okay. Okay.
Cool. All good.
Yeah.
Any questions? Sweet.
No.
Yeah, so now since we made some improvements, but it still can be improved. Any thoughts? Secure. That's the solution architect pro certificate for you. More database. We'll get onto that later. So have you wondered where it's going to be heading? Because in computing, it's always going to be IP address exchanging the data, right? So how do you make sure, like when you try to access a website, what exactly it? That's exactly it. So yeah, so if you're searching for Amazon, like try to find some product, you obviously go like www.amazon.com, right? Instead of the IP address of the Amazon website. So this is what we're trying to add here. So there's a DNS server in AWS called Route 53. Everyone knows what DNS is, right? You guys are smart. So yeah, we add the Route 53 in there, and then so this is a domain server that provided by AWS. So it has a couple of features. So for this case here, we adding an A record, which is targeting the www.something.com, and it has a TTL of 1 hour, which we can specify that as well. Anyone know what TTL means? That's good. Yeah, good, right answer. So essentially, what it does is you would try to build a session, and then when you but you don't want to repeat the request every time when you make the similar or same request. So that's when you have the connection of time to live. So during this 1 hour, yeah, no, so now we added that, so it will give our user easier access when they're trying to query something or use the website. So that's another improvement. So are there any more improvements that we can make? Maybe I'll set a direction. So if instance failed, what can we make to improve that? Yes, so essentially if one instance were accidentally or planned to shut it down, but there were still requests coming in from the users to the EC2, that specific EC2 instance. That's right. So that's what we need to address here. So because if you notice, the TTL is set to 1 hour, and if the EC2 instance were shut it down accidentally during that 1 hour period, the first top 2 users will still be accessing the same EC2, will still try to get the information from the first EC2 instance, and that will cause, well, some outage, right? So that means those requests will be dropped. And obviously, if you're maintaining the website, you don't want that to happen. So by addressing that, like that gentleman over there mentioned, we want to add the load balancer in between. So yep, that's the right answer. So obviously it has a lot of features and capabilities, but in here for today, we'll just cover the basic, which is distributing the load and also checking the health status of the instance. Because if one instance failed, obviously you want someone to know, and not distributing the load to there. So load balancer has its built-in capability of health checking.
Mm-hmm.
Right. Any more improvements? So another issue we might be facing is at the moment we only set 2 EC2 instances. If the more requests are coming in, and we obviously need to manually add those EC2 instances. And as a developer, you don't really want to do that, because you want to try to automate everything. Even sometimes it takes longer to write the automation code than manually do it, but still it's a good habit, just in case someone forgets. So in here, there's a capability in AWS called ASG, which is also known as the auto scaling group. So this is, like Susanna mentioned earlier, which will help us to accommodate the load on demand, and also or you can design it based on the time cron job as well. So yeah, so if we add that part into the application tier, then we can say when the CPU of both EC2 instance exceeded 80% usage, then spin up another new EC2 instance. Or if it's lower than 30% for each, then we can shut down one. So that way we can pay less for the billing, because AWS follows the pay-as-you-go pricing model. So you only pay for what you use, and this is a sort of the smarter way of managing your resources and paying less bill. So yeah, just a quick recap. I know we are running a bit over time. So yeah, we have 5 stages in total. So the first stage is just a basic web application, and then second is we add more service when traffic is busy, and which is EC2 instance. And then for the stage 3, we add the domain name service for querying for easy access. And the 4th stage, we add the load balancer for request distribution, also known as elastic load balancer. And the 5th stage is adding the auto scaling group, so we can adjust the application tier based on demand. Any questions? I'm not going to bite you, so.
No, this was really good.
Cool.
I learned a lot.
Awesome. That's good to know. Yeah. So that if you are interested, maybe in the next meetup, I can do a part 2 of today's session. So
Yeah, that would be really good.
cool. Awesome. I'll start preparing the slides.
Thank you. Really appreciate it.
All good?
All good for now.
Nice.